All right, today's lesson is 5.2. We're talking about relations and functions. We did talk about this yesterday a little bit. So, A, relation is any set of ordered pairs. Domain are the x values, which are the inputs or the independent variables. The range is the y values, which is the output or the dependent variable. So every set of ordered pairs in the world is a relation. And then there are special relations called functions. A function is a relation that assigns every input value to exactly one output value. I'm going to tell you what, when I was a kid, that sentence, and even to this day, I'm not in love with that sentence. I like to think of it this way. This is a Teresianism. I'm not claiming that this is the best thing ever, but it makes it easy to understand. A function, every x has to be different. Whoops, not b, b. Has to be different. Every x has to be different. One way to tell if a relationship is a function is by making a mapping diagram. I'm going to show you what that is in a minute. First time I kind of think that this is a waste of time, but I want you to understand what it is. All right. Determine whether it's mapping function or mapping diagram. You have it? Okay. Determine whether each relation is a function. If it is a function, tell me its domain and range. First of all, I'm going to look at this without a mapping diagram. Look at the x values, 11, 12, 13, and 20. Is this a function? Yes, a function, because all the x's are different. Yes, a function. You guys notice? I didn't even look at the y value. All I did was say 11, 12, 13, and 20. They are all different. It is a function. Domain. Oh, that's a terrible looking. Okay. What's my domain? What's my smallest number in my domain? 11. What's next? 12, 13, and 20. My domain are my x values, or my input, or my independent variable, whatever you want to think of it as. My range, tell me what my range is. -2, -1, -2, -1, and 7. I hear Katrina saying, but there's another -2. You don't list it twice. That's my range. Those three numbers. Okay? Now, this is what a mapping diagram looks like. Okay? A mapping diagram. Here's my x, 11, 12, 13, and 20. Here's my y, -2, -1, and 7. 11 maps to -2. 12 maps to -1. 13 maps to -2. and 20 maps to 7. Do each one of, are all these different? Yes. But really, that's just another way to look at it. I would never, ever in a million years waste my time doing it. Right? You can look at this and see if it's a function. Look at this second one. Look at the x values. -2, -1, 6, and -2. Is this a function? No, it is not a function. And they told us we only had to list the domain and range. If it wasn't range, if it was a function, so it's not a function. All right. Another way to tell if a relation is a function by using, when you have a graph, it's using the vertical line test. And I talked about this yesterday. Of the vertical line test, if a vertical line touches the graph at 2 or more points simultaneously, it is not a function. Otherwise, it is a function. We say it passes the test if it touches once. It fails the vertical line test if it touches twice. So, I'm going to use green for this. Here's my function. I'm going to, with my eyes, but I'm going to draw it right now, I'm going to draw a vertical line. It crosses once, 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 once. If I continue to go, would a vertical line ever touch that thing more than once? So is that a function? Yes, a function. Oh, you know what? Look what they did. They gave me a vertical line over here that I could move. Look. Once, 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 once. Is this a function?
Yes.
Yes. Now, I can go back here. Take this vertical line. How many times does that vertical line touch that function or that picture? Twice. So is this a function? Not a function. It fails the vertical line. Not a function. Now, let's talk about why that is. Oh, that's not what I want to do. Why that is. Look here, guys. If I use these 2 points, this point right here is x is 1, y is 1. This point right here, x is 1, y is -1. If points are right on top of each other, don't they have the same x value? So it fails the vertical line test. All right. Let's look at this. Is this a function? 3, -2, 0, -3, 3. Is that a function? Are all the x values different? No, so it is not a function. Now, if we want to prove it, let's graph it. 3, 0 is right here. -2, 1 is right there. 0, -1, -3, 2, and then 3, 2. If I did my vertical line test, wouldn't it fail?
Yeah.
Right there, failed. Not a function. Okay, another way to write a function is, and we talked about this yesterday too, y equals 3x plus 4 is f of x. F of x is 3x plus 4. F of x is called function notation. F of x still indicates the output. You might also see g of x or h of x or whatever, but it's always going to be x in there. Yes. Because that's not what it is. It's not times. This is function notation. This is not f times x. It is f of x. It's function notation. All right. Now, watch how easy this is. Make a table for f of n equals -2n squared plus 7. Use 1, 2, 3, and 4 as the domain values. So I'm going to make my table. What are my 2 columns? columns in a table. What and what? X and Y. But when we're doing function notation, this is going to be f of n, and this is going to be n. They're the same thing. What are my input values that they're telling me they want us to input? 1, 2, 3, and 4. Those are my input values. Now, guys, I'm going to write my function notation. F of n equals negative 2n squared plus 7. All I've done is recopy it. What's my first value that I want to input? Watch how I'm going to write this. F of 1 is negative 2 times 1 squared plus 7. All I'm going to do is substitute 1 in for n. That's my input. So, f of 1 is, what's 1 squared? 1 times negative 2 is negative 2, plus 7 is 5. So, my first ordered pair, when I input 1, I output 5. My ordered pair is 1, 5. Yes? Correct. All right. I'm going to do the same exact thing, except what's my input here? 2. So what am I going to write? I'm going to write f of 2. That's showing what you're inputting. You are showing x. You're showing the input is negative 2 times 2 squared plus 7. Now, you see that? Let's do our order of operations. What's 2 squared? 4 times negative 2 is negative 8 plus 7 is, so f of 2 is negative 1. So my next ordered pair is 2, negative 1. What am I going to do next? F of 3 is negative 2 times 3 squared plus 7. So, f of 3, let's do the math. 3 squared is 9. 9 times negative 2 is negative 18. Plus 7 is negative 11. Are you guys following my mental math there? Yes. Okay, so my input is 3. My output is negative 11. That's my ordered pair. 3, negative 11. Last one they want us to do is f of 4. So I'm going to do negative 2 times 4 squared plus 7. 4 squared is 16 times negative 2 is what? Negative 32 plus 7, negative 25. Did I do my math right? Yeah. Now, since we had a lot of questions about last night's homework, I think it would be a good idea to do this. I'm going to erase this to give myself room. I want to show you how this is related. I'm going to change color of pens. Pretend I gave you this table. Let's find our rule, our pattern. What am I doing to 5 to get to negative 1? Oh, you know what? I'm not going to do this. And you know why? Because this is an n squared. You guys are not at the point where you can write a function rule with a squared yet. It has to be linear. And that would just have to be n. Okay? Now, similarly, you can find use a table to find the range of the function. Evaluate this function rule. F of a is negative 3a plus 5 to find the range of the function for this domain. Let's set up our table. What's going to go here? What goes here? X. Well, which is A. What goes here? Y, which is f of a. Okay, domain. Is my domain my x value or my y value? X. So my domain is negative 3, 1, and 4. They want us to find the matching range.